Let's start with number 2. So evaluate the 6 trig functions of the angle theta. When doing problems like this, just be careful where your theta is, because sometimes it could be down here, sometimes it'll be up here. So just make sure you look and see where your theta is at. Our theta is up top, so we're dealing with that angle up there. This side would be opposite. Is 4 adjacent or hypotenuse? Adjacent. And that would mean 9 is our hypotenuse. We don't know what our opposite side length is, so how do we find that length? The Pythagorean Theorem. So 4 squared plus, we can call it x squared because we don't know what it is equal to our hypotenuse squared, which is 9. 4 squared is 16. Plus x squared is equal to 81. Subtract 16 on both sides. So we get x squared is equal to 65. How do we find what just x is? Square root. So we get the square root of 65. Can we simplify the square root of 65? Nope. You can always check, what are your factors of 65? We have 5 and 13. Can't break down 5 anymore, can't break down 13 anymore. So we don't have any pairs, so we can't simplify 65. So our opposite side length is the square root of 65. Not super pretty, but we can deal with it. To find our 6 trig functions, we're going to need SOHCAHTOA. So let's start with sine. Sine is what over what? Awesome. Opposite over hypotenuse. So our opposite is square root 65, and our hypotenuse is 9. So sine of theta is square root 65 over 9. Next we have cosine theta. Cosine is what over what? Adjacent over hypotenuse, so 4 over 9. And then tangent of theta is what over what? Opposite over adjacent. Yep. So square root 65 over 4. And then we have the reciprocal of each. So cosecant, secant, and cotangent. So cosecant is the reciprocal of sine, so we just flip it. We have 9 over square root 65. Can we leave our answer like this? No. Nope, we can't have a square root on the bottom, so how do we get rid of that square root on the bottom? Multiply the top and the bottom by square root 65. So on the top, we get 9 square root 65, and on the bottom, we get 65. Always check and see if you can simplify this anymore, but 9 doesn't go into 65. They don't have anything in common, so that's our answer. Now secant is the reciprocal of cosine, so we just flip it. So 9 over 4. Can't simplify, so we're good. And then cotangent is the reciprocal of tangent. We flip it. We have 4 over square root 65. Again, we can't get square root 65 on the bottom, so we multiply both the top and the bottom by square root 65. So we get 4 square root 65 over 65. Can't simplify, so that's our answer. So these are our 6 trig functions. So let's take a look at number 8. Here we need to find the value of x for the right triangle. So it gives us this angle down here, which is 60 degrees. What is x for 60 degrees? Is it adjacent, opposite, hypotenuse? Adjacent. It's right next to it, so that is adjacent. And then what is 16? The hypotenuse. It's across from the right angle. So again, we want to know SOHCAHTOA. Out of SOHCAHTOA, which one involves adjacent and hypotenuse? Adjacent and hypotenuse. Oh, is that what you said? Sorry. Cosine. So we want to take the cosine of 60, and that's equal to adjacent over hypotenuse, so x over 16. 60 is one of our special right triangle ones. So cosine of 60 is 1/2. We know that just by looking at that chart from 9.1. So 1/2 is equal to x over 16. How do we solve for x from here? We can cross multiply, or we can just multiply both sides by 16. Either way works. It's like one step less doing it this way, I think. But you could definitely cross multiply, you'll get the same thing. So we get x is equal to 16 divided by 2, which is 8. On the test, you could see a problem like this that isn't one of your special right triangles. So let's say this was like the cosine of 32. Not a special right triangle, but you can always put the cosine of 32 into your calculator and figure out what that is. So if it doesn't give you a special right triangle, just put it in your calculator. If it is a special right triangle, it'll probably ask you for an exact answer, because some of our special right triangles are like square root 3 over 2. So if you put that into your calculator, it'll get you a decimal, so that would not be an exact answer, but it'll be specific on what it asks. So if it says leave it in an exact answer, you know it's not a decimal. You need that like square root or fraction in it. Any questions on this one? Some questions on the test might say solve the triangle. So if you have to solve the triangle, you have to find all the missing parts of it. What would this angle up here be? How do you know that? Awesome. You could add 90 and 60. So 90 plus 60 plus x, whatever this angle is equal to 180. All the angles in the triangle are going to add up to 180. So you would just subtract, and we get x is equal to 30. So if it gives you one of the acute angles, you could always do whatever that angle is, 90 minus that. All right, let's look at 10. A cable is attached to the top of a pole and mounted to the ground 3 feet from the base of the pole. The angle of elevation from the mounting to the top of the pole is 78 degrees. Estimate the height of the pole. Round your answer to the nearest tenth. So first thing we want to do is draw our picture. We have a cable attached to the top of the pole. So this would be our pole. Cable is from the ground to the top. And from the ground 3 feet from the base of the pole. So this would be 3 feet. And let's see, what else do we know? The angle of elevation, so from the horizontal line up, is 78 degrees. So this is 78. And we need to find the height of the pole. So if 78 is our theta, what is x? Opposite, adjacent, hypotenuse? Opposite. And what is 3? Adjacent. So which trig function involves opposite and adjacent? Tangent. So we would take the tangent of 78 degrees. And that's equal to opposite over adjacent, so x over 3. This is one of those where 78 is not a special right triangle, so we would just put it into our calculator. Tangent of 78 is 4.704. And that's equal to x over 3. How do we solve for x? Multiply 3 to both sides. Since x is being divided by 3, we do the opposite of division, which is multiplication. So x is equal to 3 times 4.704. What do we get? 14.1. What unit? Like, awesome, feet. Let's take a look at number 6. So draw an angle with the given measure and standard position. So just looking at negative 4 pi, we don't really know what that looks like on our graph. Maybe you do off the top of your head, but it always helps to change it to degrees so we see where exactly we need to be. So what do we need to multiply by negative 4 pi to get this to be degrees? 180 over pi. So the pi's cancel, and we have negative 4 times 180, which is negative 720. So we can draw our plane here. Negative means that we go starting down. So you always start here. This is your initial side. And then we go down. Around one time would be negative 360. How much more do we have to go after that? One more full length around. So another 360, because that would give us negative 720. We end up in the same spot. All right, let's take a look at 11. Find one positive angle and one negative angle that are coterminal with the given angle. What do we need to do to find a positive coterminal angle? Add 360. So negative 420 plus 360 is what? Negative 60. Did this give us a positive angle? No. So what do we have to do? Add 360 again. So 360 minus 60 gives us 300. So this is a positive coterminal angle. What do we do to find a negative coterminal angle? We could subtract 360, but we actually already found a negative coterminal angle here. So negative 60 would count as a negative coterminal angle, or we could do negative 420 and subtract 360. Did anybody do it this way? What did you get? Negative 780. So either one of these would work as a negative coterminal angle. It just wouldn't work if you gave me a negative angle and said it was a positive one. All right, let's look at 13. We need to convert the degree measure to radians or the radians to degrees. What do we need to multiply to change degrees to radians? Pi over 180. So we can simplify, cross out the zeros. We can divide 20 by 2. We get 10. We can divide 18 by 2 and 9. So we get 10 pi over 9. And let's do 16. How do we change radians to degrees? Multiply by 180 over pi. So the pi's cancel. We can divide 180 by 10. We get 18. And 3 times 18 is what? 64? 54. And remember, whenever you're talking about degrees, make sure you put that little degree symbol there if you need it. Any questions? All right, 27. The observation deck of a building forms a sector with the dimensions shown. Find the length of the safety trail and the area of the deck. So first we want to find the length. What's our length formula for arc length? So arc length is equal to radius times theta. What does our theta have to be in? Theta always has to be in radians. So our arc length is equal to, what's our radius? 10. And then we need to change the degrees, because it gives us 90 degrees here as our angle. We need to change it to radians. So how do we change 90 degrees to radians? Multiply by pi over 180. Awesome. Pi over 2. So here we would have our arc length is equal to 5 pi. We put this into our calculator, we get 15.7 yards. Next, we need to find the area. What's our area formula?
For the test, can we leave it like as 5 pi?
What's our area formula? 1/2 radius squared times theta. So we have the same radius and the same theta that we used in the first one. So 1/2 10 squared times theta, which we said was pi over 2. So our area is equal to 100 pi over 4. So our area would be 25 pi. I didn't put this into the calculator, but it would be 25 pi yards squared. Just remember, area, the unit's always squared. So let's take a look at number 3. We need to evaluate the 6 trig functions of theta. So it gives us our point here. 2 is our x. -4 is going to be our y. We need to find r. How do we find r? Pythagorean Theorem. So we have 2 squared plus -4 squared is equal to r squared. So 4 plus 16 is equal to r squared. 20 is equal to r squared. So r is equal to the square root of 20. Can we simplify this? Yep. 20 breaks down into 4 and 5. And then 4 breaks down into 2 and 2. So we have a group of 2's that we can take out. So this would be 2 square root 5. So always simplify it if you can. So our x is 2, our y is -4, and our r is 2 square root 5. So all you need for these is your x, y, and r, and then you can plug everything in. So sine is what over what? Alright, so sine of theta is y over r, so we have -4 over 2 square root 5. We can simplify this. We get -2 over square root 5. Can we leave our answer like this? Nope. Gotta multiply top and the bottom by square root 5. Get rid of that radical in our denominator. So we get -2 square root 5 over 5. Next, let's find our cosine. Cosine is what over what? X over r, so we have 2 over 2 square root 5. 2's cancel each other out. So we have 1 over square root 5. Again, we have to rationalize it. So we get 5 square root of 5 over 5. Next, let's find our tangent. Tangent's what over what? Y over x, so negative 4 over 2. What does this simplify to? Negative 2. Now we find the reciprocals of each, so we have cosecant, which is the reciprocal of sine. So sine, we said, was negative 2 over square root 5, so we just flip it, so square root 5 over negative 2. And it doesn't matter where you put the negative, because you could say negative square root 5 over 2. You can put it up top, out front, bottom, doesn't matter. All the same thing with the negative. Next, we have our secant. Secant's the reciprocal of cosine. So cosine was 1 over square root 5, so we flip it, square root 5 over 1, which is just square root 5. And then lastly, we have cotangent, which is the reciprocal of tangent. So instead of negative 4 over 2, we have 2 over negative 4, which simplifies to what? 1 over negative 2. Perfect. Any questions on this one? Let's look at number 7. So we need to use the unit circle to evaluate the 6 trig functions. Whenever it says unit circle, what does that give us a clue about? R is equal to 1. And we need to figure out where this is on our unit circle to see what x and y are going to be equal to. Do we know where negative 5 pi over 2 is on our graph? Just by looking at negative 5 pi over 2? Not really. So how do we change this to degrees? Multiply by 180 over pi. So the pi's cancel. So we get negative 5 times 90, which is negative 450. So we're going to go around our circle in the negative direction one time. And how much farther do we have to go? Go around another 90 here. So we are down here. So on our unit circle, our point to the right would be 1, 0. Our point up top would be 0, 1. Our point to the right is negative 1, 0. And our point down at the bottom is 0, negative 1. So our graph ends at that point at the bottom. So we're using this one. 0, negative 1. So x is 0, y is negative 1. Now we just need to find our 6 trig functions. So sine of theta is what over what? Y over r. So negative 1 over 1. What does that simplify to? Negative 1. Cosine theta is what over what? X over r. So 0 over 1, which is 0. And then tangent is what over what? Y over x. So negative 1 over 0. What does that simplify to? Undefined. Anytime you get 0 on the bottom, it is undefined. So let's find our reciprocals now. We have cosecant. So we just flip sine, so that would be 1 over negative 1, which is negative 1. Then secant, we flip cosine, so that would be 1 over 0. What's 1 over 0? Undefined. Again, we have 0 on the bottom, can't do that, so it's undefined. And then cotangent, 0 over negative 1, which simplifies to what? 0. Alright, let's do number 11. So we have to find the angle's reference angle. To find our reference angle, we need to figure out what quadrant we are in, and then we use a different formula depending on which quadrant we're in. So if we're in the first quadrant, our reference angle is equal to whatever angle we're given. So theta prime is equal to theta. If we're in the second quadrant, theta prime is equal to 180 minus theta. Third quadrant, theta prime is equal to theta minus 180. And fourth quadrant, theta prime is equal to 360 minus theta. So these are 4 formulas we need to know. How can we figure out where 13 pi over 4 is? Change it to degrees, so we need to multiply it by 180 over pi. Simplify, 4 goes into 180 45 times. And 13 times 45, 585. So 585, we're going to go around the circle 1 full time. How much more do we have to go after that? How do you know we have to go 225 degrees more? We're going to subtract 360 to show that we just went around 360 degrees. We went around 1 full time, so we're going to subtract to see how much more we have left to go. So that would be 225. So we're going to go around another 225 degrees. What quadrant would that put us into? The third, because this is 90, this is 180. The third, we're not quite to 270 yet, so we're in the third quadrant. So we're using theta minus 180. What's our theta? $225. So 225 minus 180, what does that give us for theta prime? 45 degrees. Are we done? No, because our question gave us radians, so we need to put our answer in radians. So, how do we change 45 degrees back to radians? Multiply by pi over 180. So, we have 45 pi over 180. What does this simplify to? Pi over 4. Perfect. Alright, 14. Evaluate the function without using a calculator. So these are those problems where we have 3 steps. Step 1, find our reference angle. Theta prime. Okay, how do we find our reference angle for 240 degrees? Yeah, first we have to graph it. So where would 240 be? Which quadrant? The third quadrant. In the third quadrant, our formula is theta minus 180. And our theta is 240, so theta prime is equal to 240 minus 180. So theta prime is 60. What's step 2? look at the chart. So on our chart from 9.1 notes, what's the cotangent of 60 degrees? Square root 3 over 3. So step 2 is the chart. And what's step 3? To see if it is positive or negative. So that is our all students take calculus. All students take calculus. In the third quadrant, we have that t. T means tangent's positive. What do we know about cotangent in the third quadrant? It is also positive. So positive square root 3 over 3 is our answer. Let's look at 16. Step 1, find our reference angle. Do we know where negative 5 pi over 6 is? It's in the third quadrant. Negative. Negative in the third quadrant. It's still going to help us to put this in degrees though. So we would multiply it by 180 over pi. Negative 150. If we just plug this into our theta prime is equal to theta minus 180, we get a negative number. Negative 150 minus 180 is going to be negative. So we need to find the positive version of this angle, the positive coterminal angle. So the same thing, but the positive one. So how do we find the positive version of negative 150? Perfect. We add 360, which would be 210. So our theta is 210. Subtract 180 from that. What do we get for our theta prime? 30. Step 2, look at our chart. So we need to find the secant of 30. What is it? 2 square root 3 over 3. And then step 3, we have to figure out our sign. Is this going to be positive or negative? So we have all students take calculus. Awesome. Only tangent and cotangent are positive in the third quadrant. So that means secant is negative. So we have to use our all students take calculus to figure out the sign. In the third quadrant, only tangent and cotangent are positive. So that's how it's negative. And we're dealing with secant here.
Oh, okay.